Hello all, welcome to video lecture series on smart system design, lecture number 3. Myself, Dr. C.H. Rajendra Prasad, Professor, Department of ECE, SR University, Warangal. In this lecture, I am going to discuss about basic input-output interfacing, where I can interface switch and light emitting diode. These are the two basic input-output devices. First, we need to discuss light emitting diode, its operation. Light emitting diode. LED stands for light emitting diode. So here you can see these are the symbol. This is the symbol of a light emitting diode. It is having two terminals. They are named as anode, and this is cathode. And these outside arrows indicates light is emitting from the diode. And all we know that when we forward bias the diode, the current is flowing. But in case of light emitting diode, when we forward bias this diode, the light is emitting from the LED. And the LEDs look like this. And to identify the terminals of the LED, we need to see longer needle and shorter needle. So here the longer needle is the anode and the shorter needle is the cathode. Types of LEDs. So there are several types of LEDs are available in the market. 3 mm LEDs are there, 5 mm LEDs, 10 mm, 20 mm, 50 mm LEDs are also there. These are normally we are used in our laboratories, and bicolor LEDs. So they can produce two different colors, green as well as red, based on the uh, inputs A and B. If input A and B is equal to 0, 0, it is off condition. Both are off condition. Input uh, A, B also equal to 1, 1. Both colors are off. Both LEDs are off. But when you are providing 0, 1 combination, so green LED will be turned on, and 1, 0 combination, red LED will be turned on. So that means it can able to produce two different colors. One is green LED and red LED. And we are also having multicolor LEDs. In the multicolor LEDs, we are having three terminals. The LED is having three terminals, where inside we are having two different LEDs. One is red LED and another one is green LED. By providing different voltages at A1 terminal, LED2, and LED1, A2 terminal, and the cathode is connecting ground, it can generate different colors. The mixture of these two basic colors will produce multicolors. And in addition to this multicolor LEDs, we are also having surface mount LEDs, which are available on the several PCBs, and flashing LEDs. These are used in our mobile phones and flashlights, and high power LEDs normally we are used in our homes. These are the different types of LEDs available in the market. Then coming to this 3 mm LEDs, 5 mm LEDs, which we are used in our laboratory. So let us see the specifications or technical specifications of LEDs. Here the forward current IF is 20 milliamps. The peak forward current is 30 milliamps. The suggested current is in between 14 to 18 milliamps. The forward voltage must be in between 1.8 to 2 volts. Then only the LED is glowing. Otherwise, it will be off or it may be damaged. So that means we need to remember that when you are connecting to our Arduino, you need to maintain the voltage in between 1.8 to 2.2 volts only. And coming to connecting LED to Arduino UNO, so let us consider here this is 13th pin. This 13th pin is a digital IO pin. This 13th pin is directly, if you directly connect LED to Arduino UNO, so the LED may be damaged. Why? Because the Arduino UNO digital output pin able to produce two different voltages. One is 0 volts and 5 volts. When it is producing 0 volts, nothing will be happen to uh, LED. But whereas when we are the 13th pin is producing 5 volts, in that case, here the LED may be damaged. Why? Because already we know that the forward voltage drop across the LED should be in between 1.8 volts to 2.2 volts. So a current limiter must be used. So that's why we are used here a resistor. But we need to find the resistance, how much resistance we need to provide uh, to protect our LED. Let us calculate this one. Let us assume here the forward current is 20 milliamps, that is flowing through this LED, and apply the KVL within this loop, 13th volt, 13th pin and this ground. So V13 minus VR minus VLED is equal to 0, where V13 is 5 volts and VR is the voltage across the resistor and VLED is the voltage across the LED. So already we know that the voltage required for LED is 1.8 volts to 2.2 volts. Let us consider average of that value 2 volts. So by substituting these values, V13 is 5 volts, and the voltage across resistor is I into R here. I is the current flowing, that is 20 milliamps. R is the resistance we need to find out. 2 volts is the voltage required for the LED. And by simplifying this, we are getting R value is equal to 150 ohms. But normally we cannot get 150 ohm resistor in market. So we need to go with a higher value of resistance. Why? Because if you are choosing lower value of resistance, there may be a chance of damaging of LED. So that's why normally we will go with 220 ohm resistor. So this is the connection of LED to Arduino. When you are connecting LED to Arduino, we need to use R value should be 220 ohms only. Okay. Then types of, then we need to discuss about switches. Uh, First, we need to see the types of switches. There are several types of switches are available in the market. One is push button switch, rocker switch, toggle switch, slide switch, rotary switch, and TP switch. So these are the some of the switches available in the market. So first we need to see how a switch will work. So to understand the operation, let us consider this is the main supply and this is the bulb. One of the line uh, is directly connected to bulb and the other wire is connected through a switch here, and let us assume here if this switch is open, when the switch is open, there is no contact is made between these two terminals. That means there is no flow of current. So the bulb will be off condition. But when you are pressing the switch, there is a closed loop. That means current is flowing. So the current is flowing is nothing but the bulb is turned on. That means a switch is a device which makes the contact or breaks the contact. So if you see here in this application, it makes these two contacts when we are pressing the switch. When you are releasing this one, the switch is open. When it is open, the appliance will be turned off. So from this, I conclude that a switch is a device which makes the contact or breaks the contact. Then let us do one simple activity. One, design a smart system to turn on LED when the switch is pressed using Arduino UNO. To do this activity, first I am considering it requires some components. What are the components we require? Let us first list out. So equipment required, a personal computer where we need to install our Arduino software, and Arduino software is also required, and Arduino UNO board is required, universal serial bus is required, and breadboard. The breadboard is normally for just laboratory connections, and then connecting wires. Some connecting wires are also required, and push button switch and light emitting diode. These are the components which we require for our application. In addition to this, when we are using a light emitting diode or a push button switch, we require some resistances. So that means I am considering resistors of 220 ohms of two numbers. These are the components which we require for our basic input and output interfacing. That means push button switch and LED interfacing. Let us see the schematic diagram for the current application. First, we need to take the Arduino UNO. And one more thing we need to note that here for our application, both the switch and LED which we are choosing for our application are digital input and digital output. So that means I am considering here digital input for switch and digital output for LED. First, we need to connect LED. Here I am considered third pin where I can connect the resistor of 220 ohms. Already we discussed. Then the anode of the LED should be connected here. Then the cathode should be connected to ground. This is the connection of LED to Arduino UNO. Then we need to connect the switch to the Arduino UNO, and here we need to take the uh, digital input. Digital input. So the digital input I am considered here is 8th pin, and the other terminal of the switch is connected to 5 volts, and the another terminal here. If you are not connecting anything here, what happens? So if the switch is pressed, if the switch is pressed, the 5 volts is coming here. But when you are open the switch, a garbage value is available at the 8th pin. So in order to overcome this problem, normally we will provide the a ground signal, another 0 volt signal, that means ground signal through a 220 ohm resistor. So this is the interfacing of a push button switch with Arduino UNO. Now let us consider first how it will operate. So if you here this is switch is open. When this switch is open, this ground signal is connected to 8th pin. That means it is having 0 volts. When the 8th pin receives 0 volts, the Arduino UNO internally receives a binary number that is 0. Once this binary number 0 is received, means when switch is open, so we need to turn off the our LED. That means we need to generate 0 volts here. To generate the 0 volts, I need to write logic 0 on third pin. When I write logic 0 on third pin, it will generate an voltage of 0 volts. When this voltage is generated at the uh, output of third pin, so 0 0 0 minus 0, that means the LED is in reverse bias, the LED is in off condition. And next we need to consider other case, on state. That means switch is pressed. When the switch is pressed, now you can see here the current is moving in this direction, but there is a resistance. That means the complete voltage appears here. That means 5 volts appears at the input of digital pin 8. And once the digital pin 8 receives 5 volts, the Arduino UNO receives internally logic 1. So this logic 1, when this logic 1 is received, our intention is we need to turn on the LED. So that means I need to write here logic 1. When we write the logic 1 on third pin, it will generate a voltage of 5 volts. When it will generate a 5 volts, the resistance 220 ohm resistance of those 3 volts and remaining 2 volts is provided for the LED. Then the LED will be turned on and it will glow. So in this way our circuit will work, and this is the schematic diagram. I already explained this how the system is working for both conditions. When the switch is pressed, the LED is on, and the switch is open, the LED is off condition. Now let us try to write the code. Already we know that the program for Arduino is called as a sketch. The sketch basically consists of setup function and loop function. So within the setup, first we need to initialize our board. So already in the schematic diagram, I used two pins. One pin is 8th pin, another pin is the third pin. 8th pin is connected to switch and third pin is connected to LED. So now I need to initialize these two pins within the setup function. So in order to initialize the pins, we are having a one function in Arduino. That function is called as pin mode. This function, this pin mode function configures any digital IO line as either input or output, but our requirement, the 8th pin should be input. So that means here I am written input. And similarly, the third pin we need to program. To program this, we need to use another pin mode function, pin mode 3 comma output. Here I programmed third line as output. Why? Because I connected LED to third line. So once this is configuration is completed, then we need to close our setup function. Then, then we another most important function required for Arduino Sketch is the while loop. So within the loop, we need to write our actual application. So our application here, first we need to uh, read the switch position or sense the switch position. Based on the switch position, we need to turn on the light or turn off the LED. So means first we need to read the data through 8th pin. Okay, so to read the data from 8th pin, we require a digital read function. So the syntax for digital read function is uh, here you can use a type of data which you are reading from digital input, and this is a variable which stores the information from the 8th pin, and digital read is a function which reads the information and it will store within a variable called x here, and here we are having only two possibilities, so that's why I'm declared the data type for this variable is int. That means the x may contain either 0 or 1. As per our circuit, we may have only either 0 or 1. If the switch is pressed, logic 1 is available. If switch is opened, logic 0 is available. So once we read the information from the switch, then we need to check this condition. Is either switch is pressed or not. So let us take a simple if condition here. If x is equal to 1, that means I am assuming that switch is pressed. If switch is pressed, as per our problem statement, we need to turn on the light. To turn on the light, I need to send the logic 1 onto third pin. So to send the logic 1 onto third pin, we need to use digital write. Why I'm using digital write? Third pin is a digital input already I programmed. So that means I need to use digital write function to write the logic 1. Then only it will generate, third pin will generate the 5 volts. So to turn on the LED. So that means I am written here digital write 3 comma 1. So once I write this in function, the LED will be turn on. But suppose, for example, if this condition is not satisfied, that means x is equal to 0, but I am checking for x is equal to 1. So that means this switch is not pressed. When this switch is not pressed, this function will not be executed. It will goes to else condition. Else condition is nothing but x is having 0. X is having 0 is nothing but switch is open. Once switch is open, what we need to do? As per our problem statement, we need to turn off the LED. To turn off the LED, we need to write digital write 3, 0. So this command will generate a voltage of 0 volts at the third pin. So whenever the third pin is equal to 0, the LED will be automatically off. So this is the program for controlling of LED by using a push button switch. Okay. Thank you one and all. Please like, share and subscribe.